a report on our progress with a modern construction material and with the engineering developments in the construction field which it has made possible. Let's turn for a moment to recent history. Do you remember this? The 1933 World's Fair. Do you remember the new styles, the bright modern appearance of the buildings? Do you recall the interest these things had for home builders? Yes, in the 1930s, a new and promising home construction period was beginning. New materials, new designs, new construction techniques were either introduced or promised for the future. And Americans went for the modern idea as only Americans can. They put them on paper. They wrote them into contracts. They poured them into concrete and built them into the floors and walls and rafters of their new homes of the 30s. Until... Today, however, Americans look forward to our return to peaceful things. Today, our plans, our hopes are becoming real again. Our men and women are looking homeward. Hopes and plans, houses, homes, these things are symbols of the peace, symbols for the least among us, as well as for the greatest.
The Minister of Health, Mr. Woolwich, has recently outlined, and by which we shall have 2 or 3 100,000 permanent houses built or building by the end of the first 2 years after the defeat of Germany. But I do not think we can maintain our position in the post-war world unless we can handle easily and with comprehension the problems and inventions of the new scientific age. Then there is the very far-reaching policy of a national health service, which your Minister of Health...
You spoke for England, Mr. Churchill, but you also spoke for us. For we shall handle with comprehension the problems and inventions of the new scientific age, and we shall build hundreds of thousands of homes during this post-war return to peacetime activities. Every survey points to the size of this home construction job to be done. If this 13% of the nation's families do build, there will be an unheard-of market, 4 million new homes. If the predictions of private interests and government agencies are correct, we can realistically expect to build over 1 million homes a year for a 3 to 5 year period. Homes for those who want something better. New homes, which we can expect to be the best products of the new scientific age and at the lowest possible cost. Now, the cost of constructing almost anything can be cut by standardizing on materials and by mass production. America's outstanding example of this is, of course, transportation. Standardizing on models and mass production of them has lowered the cost and provided better cars for America. Likewise, improved building materials, standardization of these materials, and mass production of them can make possible better homes at lower costs for post-war American home builders. In fact, it is already being done by private enterprise and by Uncle Sam. Here are government homes, and here are private homes. Multiple housing projects built with modern materials and on a semi-mass production plan. Homes built with strand steel, one of the modern new materials, one of the engineering developments of the new scientific age, introduced to America in the 30s, recognized by architects and builders as an important new material for the post-war period. Yes, here are lightweight alloy steel framing sections designed for use as studs, joists, and channel plates in the homes of tomorrow. Heavily coated with a special red paint, these strand steel sections resist rust and when properly combined with other materials, give a completely fire-resistant structure. Here, for instance, is a joist section with all the benefits of steel, plus the advantages but none of the disadvantages of wood. For instance, the patented nailing groove. Any standard collateral material can be attached to it with a hammer and nails. As the nail enters the groove, it is bent and held tightly between two steel jaws. The nail is held with a grip that averages 25% stronger than wood. Each type of framing section can be quickly and easily anchored to other parts of the frame by means of special attachment holes. Short, thick sheet metal screws are used to make the attachment secure. Only 2 are required at each connection, an important reason why use of this modern material cuts labor time spent in erecting the frame. Once in place, the structure keeps its shape. The distortions that occur from expansion and warping of wood are unknown with a steel frame. If last-minute changes are to be made on the job, this material can be cut with a power saw in the same way as wood. Light in weight, easy to handle, with a variety of available lengths and gauges. All strand steel framing sections are designed to fit the modular planning program of the Producers' Council. All the sizes conform to the standard 4-inch module, permitting architects and draftsmen to use the 4-inch grid method for reference in planning and in establishing dimensions in drawings. Here at last, then, is a truly mass-produced, standardized construction material available in single pieces or in volume from one of the largest plants in America, making light steel framing. Now, how is this material used on actual jobs, particularly on multiple housing projects? What are the erecting techniques that work best with strand steel? Let's get our answer from a contractor like this one, a builder with broad practical experience in the field of multiple home construction.
How do you do? I'll be glad to tell you what we know and show you some of our methods. Now, we've been using this strand steel right along, pretty largely on jobs where we're putting up a number of dwellings in one area. I'll talk today about our experience in the Norfolk area, a Navy project that we put up after securing the contract on a competitive bid basis. We made some movies of the project as we went along, and that's what I'm going to show you. These are our own homemade movies, so to speak. But some of the shots came out pretty good. At least they'll give you an idea of what you can do with strand steel on the job. Now, here's one of our first steps in the construction of a single-family dwelling. These are the forms for the concrete foundation. Central heating and laundry facilities for the community eliminated the need for basements, although each home could have had one. The laying of the concrete floor was a matter of pouring and leveling. This made possible all of the advantages and economies of ground-level concrete flooring. Bolts were set in the foundation offset. This gave us a very rigid attachment of the unit framework. And notice that the offset has been waterproofed. Strand steel channels are quickly and easily bolted onto the concrete foundation at the offsets. Here's where we started to save labor time on the job. Labor for this type of work is easier to get, and the structure goes together much faster. Studs and members were brought from stockpiles already cut to size. They were laid out on the concrete floor. You see, we standardized on most of our dimensions, so we did only a minimum of sawing on the job. However, this shows you how we cut some of the pieces. The various pieces were simply screwed together to form the wall framework. Now, here again we save labor time by using a simpler and yet far stronger type of frame. Here's a window frame being attached to the strand steel studs before erection. Very easy to do, and it makes a tight fit. Up she goes. You can see how easily the main sections of the assembled frame can be handled. The second gable end wall is erected and temporarily braced. Now the rear wall is easily raised into place. You don't need a lot of labor to handle this frame, which is one of the reasons why we were able to underbid on this job. Easy does it, and the four walls are standing. This is a typical framework, fire-resistant, economical in erection, stronger by far than wood construction we might have used. We secured the wall studs to the channel plates with self-tapping screws. That's all we used, and we did it fast. Here's a jig table we used to assemble the roof trusses. The important thing here is that using strand steel, we could get the economies of site prefabrication from mass-produced parts by assembling the units from stockpile of pre-cut members. This shows you how the truss ends were dogged together for welding. Welding the entire truss was a matter only of minutes. Welding was not necessary, but here the size of the job made it economical. We could have bolted these roof trusses together just as well, but we were able to simplify our labor operations better this way. Now notice how the joints were cleaned and painted. Here's a finished truss, and there it goes into place in the framework of the house. 3 men are all you need to lift it. The wooden brace across the top is a temporary support. There goes the second truss. And the third truss is fitted into place. The trusses were screwed to the channel plates. And there's your roof framework, strong and rigid and fireproof. Each truss has nailable surfaces on both top and bottom. The insulating sheathing was nailed directly onto the strand steel wall studs. Incidentally, you can use any collateral material you want. Here the roof boards and roofing are going on over the framework. Here's a number of the single-family dwellings, roofed and enclosed, all completed to the same framework stage and ready for the next phase of construction. By using strand steel members pre-cut to our specifications, we were able to speed up the entire project. On some of the units, we used wire over the sheathing board as a basis for stucco. The wire was cut and nailed to the sheathing. The wire network acted as additional reinforcement for the type of stucco we used. Stucco is only one of the many exterior collaterals which you can use. You have no limitations on this point at all. Steel beads were attached to the corners. One of the greatest time savers was our system for applying stucco. We blew it onto the walls. Of course, the windows were protected while the stucco was being applied. A little touching up on the corners and edges, and the plasterer's work on the exterior was done. Here's the stucco drying on a lot of the units. Now we have some shots of the multiple dwellings. Here, the first floor wall frames have been erected on concrete foundation. Here, we're attaching the second floor joists to the supporting framework. All you need is a screwdriver. Here's a shot of the completed strand steel frameworks on the multiple dwellings. The roofing job is being started. Here you see sheets of corrugated steel being cut to size. We use these steel sheets as a base for our second-story concrete floors. Here's another shot of the entire development under roof. While we were getting the frames up, the electrical wiring and conduit for the entire project was fabricated on the site by a standardized production system. The wiring was installed in each unit through the holes which are punched in all strand steel frame members. You don't have to do a lot of cutting to bring it in at the right place. The same system is used with the plumbing. Now, these men are making up stockpiles of pre-fitted sections. Now here siding is being nailed to the sheathing on one unit. The architects were not cramped at all in their exterior designs for these homes. Work continued on the exteriors and interiors at the same time. An endless conveyor carried concrete to the second story where the floor was poured, and at the same time the glaziers took care of their end of the job. So by getting our frames up fast, we were able to keep all the trades at work right from the start. They didn't have to wait for each other a great deal. That's a room-sized composition wallboard. We nailed this material to the strand steel studs to finish the interior. Not all of the multiple family dwellings were clapboard finished. Here the spray method is being used again to complete a stucco unit. And as the construction of the various units progressed, concrete roads were laid down throughout the development. Here's the same street a few weeks later, a small community of comfortable, modern, low-cost dwellings. So there was nothing jerry-built about these homes. The strength of the steel frames and the quality of the materials we placed on the frames put these dwellings entirely out of the class of temporary housing. And yet, the cost to the Navy of erecting these buildings was the lowest cost per unit of any similar housing project at that time. Well, that's the story on that particular project. We knew what we could do with strand steel framework. We were familiar with its economics during construction. And so we bid on the job carefully and got lower estimates from our subcontractors because their work was made a lot easier and faster with the steel framing. The speed with which we built the project was something of a record. They got earlier occupancy, and we got a faster return on our investment. Speaking for our firm, that's the kind of business we like. The proof of the pudding is in the eating, as they say. And that particular kind of pudding tastes right nice to us.
Yes, and the proof of a dwelling lies in the pleasure of those who dwell in it. Here are more homes, for instance, constructed with these same modern materials and methods. Homes where durability and lasting attractiveness are in great part a product of the strength and rigidity of their frames. Homes that are the best products of the new scientific post-war age. Homes that are clean and modern, designed in whatever style is the owner's choice, with individual personality and charm. Homes that are safe and comfortable, protected against fire and storms and pests. Homes whose walls are solid and straight, whose plaster stays hard and smooth, free of cracks as the home grows old. Windows that fit snug, and doors that swing true. Homes that are the finest that can be had for the means and the mode of life of those who love, hope, sleep, work, eat, yes, live in them tomorrow.